Intermittent fasting, particularly time-restricted eating, has emerged as a promising strategy not only for metabolic health, but also for supporting brain function and protecting against age-related cognitive decline. Rather than focusing solely on what to eat, intermittent fasting emphasizes when to eat, typically restricting food intake to a window of 6 to 10 hours each day. This approach appears to influence a variety of biological processes that are directly linked to brain health, including inflammation, oxidative stress, mitochondrial efficiency, and the clearance of damaged proteins. Animal studies have shown that intermittent fasting can boost levels of brain-derived neurotrophic factor, BDNF, a protein that supports the survival and growth of neurons and is crucial for learning and memory. BDNF also enhances synaptic plasticity, making the brain more adaptable and capable of forming new connections, a function that tends to decline with age. In rodent models, intermittent fasting has been shown to reduce the buildup of amyloid plaques and tau tangles, the same pathological features seen in Alzheimer's disease. These early findings suggest that fasting may engage natural protective pathways that help the brain clear waste and repair itself. Human studies are more limited, but growing. Preliminary research indicates that intermittent fasting may improve attention, mental clarity, and executive function in some individuals, especially those with metabolic syndrome or insulin resistance, two conditions that increase the risk of dementia. By lowering insulin levels and enhancing insulin sensitivity, fasting could help stabilize blood sugar levels and reduce the brain's exposure to harmful glycation products and inflammatory signals. Some small trials have also found improvements in mood and sleep quality, both of which are tightly linked to cognitive performance. There is also interest in how intermittent fasting may activate autophagy, the brain's cellular cleanup process. This mechanism clears out damaged organelles, misfolded proteins, and other cellular debris, processes that naturally decline with age. Disrupted autophagy is thought to contribute to several neurodegenerative diseases, and fasting appears to partially restore it, at least in experimental models. Additionally, intermittent fasting supports mitochondrial health and reduces oxidative stress, potentially giving neurons more resilience under conditions of aging or injury. However, caution is warranted. The evidence in humans is still preliminary, and individual responses to fasting can vary widely depending on age, sex, baseline health, and duration of the fasting protocol. For some older adults, particularly those with low body weight, diabetes, or certain medication regimens, prolonged fasting could lead to fatigue, hypoglycemia, or nutrient deficiencies. Cognitive performance may actually decline if fasting leads to undernutrition or erratic eating patterns that disrupt circadian rhythms or sleep. Moreover, not all fasting schedules are equally beneficial. Time-restricted eating that aligns with the body's natural circadian rhythms, such as eating early in the day and fasting at night, appears to have a more favorable impact on brain and metabolic health than irregular or late-night fasting patterns. When done haphazardly or in an overly aggressive form, fasting may do more harm than good by triggering stress responses or interfering with meal quality. While more clinical trials are needed to confirm long-term benefits, intermittent fasting remains a compelling area of research for brain health. Its low-cost, non-pharmaceutical nature and potential to engage multiple cellular defense pathways make it a valuable strategy for those seeking to preserve cognitive function as they age. However, it must be approached with care and personalization. What enhances brain performance in one person might impair it in another. For now, the safest approach is a moderate form of time-restricted eating, such as a 10-hour eating window during the day, paired with a nutrient-dense diet that includes brain-supportive foods like vegetables, omega-3 rich fish, nuts, berries, and whole grains. This allows the body to benefit from fasting-related mechanisms while ensuring the brain still receives the fuel and nutrients it needs. As part of a comprehensive lifestyle strategy that includes movement, sleep, and mental stimulation, intermittent fasting may help build long-term brain resilience, but only when implemented wisely.